Welcome back to Learning with Ms. H. Today we're doing another Earth Science lesson, and we're going to be taking a look at the Mesozoic Part 2. So if you're in my class, go to the modules page, week 12, and then today's lesson, Mesozoic Part 2. If you're not in my class, follow along, and I will try to remember to put some links to some of these other videos in the description down below. So for today, you are going to start off with your Bellwork, which is to answer a question in your notebooks. The question is, how do the conditions of the time of the Triassic-Jurassic extinction compare to the conditions of Earth today? So the time that we are living in right now, how do they compare? Are there any similarities, any differences? One extension from that is to think about what that means for life today. For the lesson today, we're going to go through Jurassic and Cretaceous periods. This is a double class period, so we will have the double lesson. So you'll have a little bit more to do today, but you also have a lot more time. So you're going to watch a couple short videos, one on the Jurassic, one on the Cretaceous, and these are the short little 5 to 8 minute long videos of telling the dinosaur story. So you're going to start off with the Jurassic period here, then we're going to take notes, and then you're going to do the Cretaceous period down here, and then take notes. And then at the very bottom, this is a video that I made on one of my trips. We went over to Monument Rocks, Kansas, and did some exploration in the area looking for evidence of the shallow sea that was in this area during the Cretaceous period. So this video goes through some of that. It's pretty interesting. It's mostly voiceover because it was super cold, so we did not spend a lot of time out in the open. So we had to do some creative editing and some voiceover work on it because it was a wind chill of around negative 30 degrees when we recorded that video. But it's there. It's pretty interesting to see some of the stuff that is left behind from the shallow sea in this time frame. So take a look at that. You can see a connection to the Midwest during the Cretaceous. And then at the end down here, you have assignments that is Jurassic Cretaceous homework, and then the dinosaur exploration paper. This dinosaur exploration paper is not difficult. It should not take you very long. Just go ahead and work on both of those when you are done with the lesson. So your assignments for today are the Jurassic Cretaceous homework, which is going to be just answering some questions here based on what you've learned. So you've got some categorization. You're going to put these organisms in which time period they begin with. So you can just drag and drop them where they go. I'm not actually looking at these. These are not right answers. I'm going to throw them all here. So you're going to drag and drop them where they go. You may have some other ones that you can see that you might put into a different time frame. There's obviously more than one over here in the Cretaceous, but drag and drop, and then a multiple select, and then submit, and you'll be done with this one for the day. Your other assignment is this dinosaur exploration paper. So you're going to go to the British Museum of Natural History in London dinosaur page here. Choose 2 or 3 topics to explore and write a summary of what you learned. So not difficult. Here's the page you're going to go to. And you are going to come down here and look at some of these things, find some that you're interested in, and then just talk about what you learned from those pages. And that is it. Once you're done with that, you are done for the day. So let's jump in. Go ahead and pause the video, answer the Bellwork question, and then get something to write with, something to write on, so you can take notes during these videos and presentations, and restart the video when you're ready. All right, welcome back. Hopefully you went ahead and watched this Jurassic period video. If you didn't, go ahead and pause me, watch that, and then come back for your notes. We're going to start taking notes over the Jurassic period. So it was about 206 to 144 million years ago, and remember, we talk about time in reverse terms when we're talking about geologic time scale. So it starts at the oldest time and then ends with the newest time. And Jurassic was a period of diversification. Everything kind of blossoms and starts branching out. Remember, as we're going through this, if I go too fast, pause, finish the slide you're on, and then move on. Restart the video when you're ready. So this is an image of what the world looked like during the Jurassic period. You don't need to copy this down, but some interesting things about it. North America is north of the equator now, and we're starting to go from more of a almost sideways position to a more upright position that we recognize today. Things are kind of spread out here. China's over here now, Siberia's up top, kind of where it belongs, but not quite. And then we still have Gondwana completely together down here. Those are eventually going to break apart. All of this connection is how all of those diverse animals are able to travel from one region to another. Some of the dinosaurs that were in existence during the Jurassic. During the early time, we had lots of really large herbivores. So this guy over here. We also had some really vicious carnivores like this one over here. We started having early birds develop. Lots of different types of dinosaurs coming about during this time. And one of the more interesting ones is the Archaeopteryx. It's not one of the pterosaurs, so it does not qualify as being one of the flying dinosaurs. However, it does have the jawbone and bone structure of a dinosaur, but the bones are hollow like birds, and it has feathers like birds. So this is one of the earliest fossils that we've found that actually has feathers. This is our main connection to birds here. Some of the pterosaurs had hollow bones. Most of the pterosaurs had hollow bones. But this is the first fossil we've found that actually shows feathers. And that's what all these wispy things on the edges are the feathers. Scientists are not completely positive, but their top two things they are in belief of with the Archaeopteryx is that it is either an evolutionary link between dinosaurs and birds, or it could be a really close cousin to both. And they're not sure, there's not enough evidence to prove either way yet. Pterosaurs. So these are going to be your pterodactyls, and pterosaurs are your flying dinosaurs. They have trouble walking because their bones are hollow, and it's really hard for them to support weight when they walk. They're very good flyers, though, because they're so light. They range in sizes with a wingspan of less than a foot to up to 16 feet. So some of them are gigantic. Mammals. We have our primitive mammals here. They start spreading out, taking in new habitats, living in new habitats. You have several different types. You have some small ones. Most of them are fairly small at this time. You have some others that are starting to get larger, like the Megaconus and the Pseudotribos. Those are starting to get a little bit larger. Eventually, we're going to have gigantic mammals. Oceans are starting to fill up with fish, squid, sharks, all kinds of marine reptiles. The two main ones, the plesiosaurs and the ichthyosaurs. Those are your dinosaur reptiles here. The ichthyosaurs are actually starting to look similar to dolphins and sharks. So that's this guy up here. Okay, so that is going to be it for the Jurassic. If you didn't watch it already, go ahead and pause me, watch the Cretaceous video here. Again, it's less than 10 minutes long, and then you're going to come back and do the Cretaceous notes. And we will restart when you're ready. All right, welcome back. We are going to take a look at the Cretaceous period from 144 million years ago to about 66 million years ago. So we're starting to get very, very recent here. Again, more diversification, and then at the end we have massive death. So we start developing Cretaceous plants. These are going to be flowering plants. And these are the first plants that we see with flowers on them. They pop up very quickly. It's almost like a blink of an eye kind of thing in the geologic timeline that flowering plants start showing up. We're not sure 100% why they started showing up at this time. The only guess that scientists have is maybe some of the insects that started appearing during this time started helping with pollination, cross-pollination, and started making it possible for those flowers to form. So with the Cretaceous dinosaurs that were plant-eating, a lot of them had armor. So you have Ankylosaurus here, who has the ball on the end of his tail, kind of like a wrecking ball, and then he has all of these spikes on his back. We also have Triceratops and the Titanosaur that came about during this time. This image shows the Titanosaur with a silhouette of a human male underneath it. And down here we have the Hadrosaurs. Those are our grazers. They're not quite as tall because they're going to be mostly eating vegetation that's down near the ground. So this is the Triceratops that's at the American Museum of Natural History in New York. A lot of the images, actually all the images that are of actual fossilized dinosaurs like this are going to come from the trip I took to New York to go to this museum. So they're all from the American Museum of Natural History. So this guy, you have the full length of the dinosaur, and you can kind of see in the background the size of the people behind him. And then on the next slide, you're going to see an image of me in front of him, so you can kind of see the comparison of head sizes. So his tail goes all the way to here, his head goes all the way to here. These people are coming up to about here on him, but he is raised up about 8 inches. So in this one, you can see head size. So my head's probably only roughly about this part of him. All of the rest of this headdress is part of his armor structure. They're fairly large, but not quite as large as this guy. This is the Titanosaur, and the Triceratops is probably only going to come up to about here on him, right in this area, bottom of his belly probably. But he is down here pretty close to the ground. The yellow arrows are pointing you to my top of my head and the bottom of my feet here. It's kind of hard to see me there. I had to adjust the brightness a little bit because the room is super dark to highlight the fossils in the skeleton. But you can see his tail stretches all the way down here, and his head is actually out of the doorway. So the head is actually right in this area here. And all these people standing around, I don't even come up to knee height on him. Even if I stood on the pedestal with him, I would just barely come up to his knees. If you stretch his head and his neck out as tall as it gets, it would be way up here, partway up into this black bar at the top of the notes. So he is huge. So he's going to eat from tops of trees and those kinds of places. This is a Hadrosaur. It's actually a Cretaceous, which is from the Hadrosaur family. Both the Titanosaur and this guy were also at the American Museum of Natural History in New York. It was hard to get an image of the entire Hadrosaur in the picture from straight on because there are other dinosaurs displayed in the way, so you can't get a clear view of them. So I apologize for the glare of the window there, but you can see he's kind of got this duck-billed thing going on here with a plume on top. Not all of them have this plume. He is smaller than the Triceratops, still larger than a human. And this is our bottom grazer down on the ground level. So our meat eaters are carnivores during the Cretaceous. They're all members of the theropod group. The most famous one you're probably familiar with is going to be the TRex. Some others that you've probably heard of are the raptors. Unlike the velociraptors portrayed in the movies, velociraptors are actually about the size of a large chicken or turkey. So they're much, much smaller. So they're going to be more around this size. This is an adult male in comparison to the raptor family here. I do have some images here of a T-Rex. So this guy, this is a fossilized T-Rex here. And then this is another fossilized T-Rex over here standing up against the wall. So this guy's running, this guy's standing. And then there's another view here where you can see a closer view of the one that's standing up to see how tall he is. And then a closer view even more of the head. And then back here you've got a raptor again. This is one of the larger raptors. It is not the velociraptor. Pterosaurs. These are our flying dinosaurs, and they are going to really have a lot of change occurring within the pterosaur family here. Lots of diversification. You're going to have lots and lots of different pterosaurs come about during the Cretaceous. So we've got, a couple dozen different pterosaurs here. We actually have our pterodactyls that show up during this time. And the wingspans on these guys can be anywhere from, the smallest pterosaurs can be less than a foot from the end of one wing to the end of the other. And then some of them can be up to 16 foot wide for their wingspan. This one, the way that the wings are bent is roughly 10 foot wingspan, but if you stretch them out straight, the wingspan on this one's going to be pretty darn close to that 16 foot. So this is a pterodactyl that is on display, actual fossils of a pterodactyl at the American Museum of Natural History. Then we come up with a mass extinction. So the Cretaceous Paleogene extinction event is going to happen during this time, and about 60% of all of our species go extinct at this time. It affected land animals. It affected a few of the marine animals, but not nearly as many. All of the dinosaurs and all of the pterosaurs died out in this extinction event. All of the ichthyosaurs and pliosaurs died out during this event. And a lot of our terrestrial or land-based plants died out during this event. So 60% of all of our species all over the world died off. It's known as the KPG Extinction. As an abbreviation. And what you're seeing here is the line where you can see that extinction event happening. And we'll take a closer look here. So you have the KPG boundary right here. So you have the light colored rock below it, the dark colored rock above it. And along this boundary line, this is where that extinction event happened. So below this line, you'll find dinosaurs. Above this line, you will not. You have to get below this line in the rock layer in order to find evidence of the dinosaurs. So what caused the extinction? The current theory is the meteorite or asteroid impact theory. They believe that a 10-kilometer wide meteor struck the Earth. It is near the area that is now known as Mexico. That's where it hit. It caused shock waves, tidal waves, lots of dust and debris to be tossed up. All of that debris and dust entered the Earth's atmosphere, blocked out a lot of the sun, held in a lot of the heat. Everything heated up, almost immediately started heating up because all of that heat was trapped inside the atmosphere. It caused forest fires, climate change. So the intense heat immediately caused an issue, and then the blocking of the sun, once that heat dissipated from all of those fires and everything, the sun was blocked out still. The heat finally escaped through the atmosphere, and the climate started to cool. So we have lots of climate change globally happening here. It was enough dust and debris from this meteor to actually basically block out most of the sun from the Earth. So plants and animals go extinct because of all of the massive climate change swings that are happening, and the competition between organisms because a lot of their resources are gone as well. These tidal waves flooded everything. Shock waves destroyed habitats. All of the dust and debris raining down, the forest fires, all of that together limited the amount of resources available for all of the animals. So there was a lot of competition at this time as well. Evidence for the meteorite impact. So this asteroid impact evidence, in the area immediately around where it hit, we have what's called shocked quartz crystals. Quartz has all kinds of different colors that it can show up in, but it's typically just one color. Quartz of a given location will all be, for example, pink, or all be clear. If it's formed under super high pressures and temperatures, you can find this rainbow quartz. It's super rare. It's only actually found in meteorite craters and nuclear testing sites. So that is our evidence that we have. We know that there's been no nuclear testing in the area, so it must be from the meteorite in the crater there. Second bit of evidence for the asteroid or meteor impact is the iridium layer. Iridium is a material that is only found in space rocks. Iridium is not found anywhere on Earth except in this one layer of rock. And it's in several locations, not just one area. So it's very, very rare on Earth. We see iridium in all kinds of meteorites that make it through our atmosphere. So we know that this layer of rock came from a meteorite impact, or a meteor impact. Because of this, we know that it happened around the same time that the dinosaurs died. It is 160 times the normal levels of iridium in rock on Earth. And it is very consistent, very widespread. So we know that this meteor impact had all of this iridium in the atmosphere, and then it fell down, landed on the surface of the Earth, and became embedded in the rock layers over time. And it is right there at the same time of the dinosaurs dying. So dinosaur bones below it, no dinosaur bones above it, is what we've found. So again, this supports the evidence that it is the cause of the death of the dinosaurs, because they're all below it. Cretaceous World starts looking like this. We're still splitting apart. North America is almost where it's supposed to be. Eurasia is getting over here closer to how it's going to be, and Gondwana has broken apart down here. And then we have that Seaway cutting North America in half here that we're going to look at in the next video and in some of these slides. So here's that video, our region in the Cretaceous period. So pause me, take a look at this video, go ahead and watch it here. It's going to talk about that western interior seaway that's splitting North America in half. It goes right through Kansas and a little bit of Missouri. It gets wider and shallower over time. It goes, at one point, it goes all the way from the Rockies to the Appalachians, and then it starts shrinking down again. But take a look at this video. You're going to see the pillars that are evidence left behind of it, along with some fossils. So go ahead and stop my video, watch this one, and then get started on your homework for the day. Once you finish those 2 assignments, you're good to go, and we'll see you next time.